In the vast expanse of time stretching far beyond the limits of our everyday experience, Earth is a continually changing masterpiece, a planet in motion, shaped and reshaped over millions of years by forces both immense and slow. Imagine, if you will, a journey not just through space, but through the unfathomable depths of future time. A journey that takes us 100 million years forward, to a world transformed beyond recognition, yet bound to the same patterns that have guided its evolution since the beginning. Tonight, as you settle into a comfortable place, allow your mind to wander gently into this distant future where Earth, our familiar home, reveals its next great chapter. Our story begins with the silent, almost imperceptible dance of Earth's continents. Today, the continents appear as familiar and stable landmasses, but beneath the surface, colossal plates steadily shift. These enormous slabs of rock, vast beyond comprehension, drift like slow currents atop the molten mantle deep within our planet. Over the next 100 million years, this restless movement will redraw the world's map. The continents will drift closer together, colliding and converging to form a new supercontinent. Some call it Pangaea Proxima, a new name echoing the ancient landmass that once unified Earth's land so long ago. This union of continents will create towering mountain ranges as landmasses thrust upwards, reshaping oceans and air currents. Vast inland seas might vanish, replaced by dry, sprawling deserts or thriving forests depending on the climate. Imagine continents merging again, a world transformed through slow collision and fusion. But this journey does not stop at the surface. Earth's atmosphere and climate will undergo profound shifts that echo through every corner of the globe. In the distant future, the Sun, our life-giving star, will have grown slightly brighter and hotter. This subtle increase in solar energy will warm our planet, slowly drying out many of the oceans and creating harsher environments on land. Swaths of land that now teem with vibrant life may become arid deserts, while tropical jungles might give way to new biomes adapted to intense heat. Life itself will adapt to these changes, forging new paths for survival, thriving in niches carved out by climate and geography alike. In the shadows of these transformations, life will continue its endless dance of adaptation and evolution. The creatures that tread the Earth 100 million years from now will be unlike any we have ever known. Perhaps there will be descendants of today's species, altered by millions of years of natural selection, or entirely new forms that have emerged in response to extreme conditions. Imagine creatures that are masters of heat tolerance, capable of thriving in desert-like environments, or species that have adapted to survive in clouds of dense, humid jungles that cling to mountain slopes. The story of life will persist, ever-changing yet profoundly connected to the past. At the same time, Earth's geological heartbeat will begin to slow. As the forces beneath the surface shift and realign, the intense tectonic activity that has sculpted landscapes for eons may gradually wane. Volcanoes that once roared might fall silent, and mountain building could slow, signaling a phase of relative stability. Yet, this calm could bring its own changes, allowing erosion and weathering to tame the tallest peaks into rolling hills and plains. The balance of creation and destruction, so crucial to Earth's identity, will tip delicately between transformation and preservation. Amidst these vast shifts, the traces of humanity as we know it today may become faint whispers in the palimpsest of time. Cities, roads, and monuments all built by human hands will have long disappeared beneath layers of sediment, soil, and rock. The rise and fall of civilizations may seem fleeting against the sprawling canvas of geological epochs. Yet, perhaps humans will have transcended their earthly existence, evolving or migrating to environments beyond what we can currently imagine. Maybe the essence of our species will live on in forms not bound to flesh and bone, existing in digital realms or as far-reaching explorers among the stars. The story of humanity is but a single, delicate thread woven into the vast fabric of Earth's future. Meanwhile, the oceans, which today cradle most of the world's life, will also undergo dramatic transformation. As the climate warms, evaporation may shrink some of these great bodies of water, creating new land bridges and isolating marine environments. Some ocean basins that nurture countless species today could become deserts of salt flats and evaporated minerals, while deeper ocean trenches might hide new ecosystems thriving in complete darkness. The delicate web of marine life will adjust, persist, and evolve, responding to the ever-changing chemistry, temperature, and pressure of their liquid world. Into the silent heavens above, Earth will also be shaped by celestial forces. The steady pulse of solar radiation, occasional meteor showers, and the slow dance of the moon will continue their endless cycles. Solar flares and cosmic radiation might challenge life in unseen ways, nudging evolution further along its unpredictable path. Even rare cosmic events such as asteroid impacts could reset parts of this future world, reminding us that Earth's story is never isolated but intertwined with the cosmos itself. As this vision of a distant Earth unfolds, it invites a deeper reflection on time, not the ticking of clocks, but the immense, gradual rhythms that shape worlds and life beyond our immediate perception. It reminds us of the impermanence of the present and the ceaseless flow of change that defines our existence. The planet we call home is not static but a dynamic and evolving entity, forever weaving stories of birth, destruction, and renewal. And so, as the night settles softly around you, take comfort in this thought. Just as Earth has survived and flourished through unimaginable changes in the past, it will continue its dance into the far future, a mesmerizing rhythm, slow and majestic. This grand unfolding is both a mystery and a promise, stretching over millions of years, inviting us to imagine and dream gently as we drift toward rest. Let the images of distant mountains, vanished seas, and strange new creatures fill your mind. Let the quiet pulse of slow-moving continents and shifting climates settle your thoughts. With each breath, feel yourself sinking deeper into peacefulness, cradled by the endless story of Earth, forever changing, endlessly alive, and tenderly unfolding through the vastness of time. Here, in this calm space between wakefulness and dreams, let your mind roam freely across the ages to come. Feel the wonder of a world reborn and reimagined, a future Earth that hums with the gentle promise of life, exploration, and transformation. And as you listen, allow the steady, soothing cadence of these words to guide you softly towards sleep, deep, restful, and renewing. In this moment, where science meets imagination, where knowledge blends with tranquility, lies the timeless heart of Earth's future, a future that awaits, quietly patient, ready to embrace whatever stories the millennia will bring. Rest now, as Earth's great journey continues beyond the reach of time. Earth's surface, as we know it today, is but a brief expression in the unending saga of its geological life. Beneath our feet, the planet's crust quietly shifts and bends in a dance that can last millions of years, imperceptible in the moment yet monumental across geological time. The story of continental movement, or plate tectonics as it is known, is central to understanding our planet's future. Over the coming 100 million years, the continents will continue their slow but inexorable movements, driven by the immense and restless mantle convection beneath. Imagine continents slowly journeying across the globe, continents that today we perceive as fixed and unchanging. North America, South America, Africa, Eurasia, Australia, and Antarctica each drift toward new horizons. These landmasses move but centimeters per year, often too slight for us to notice day by day, yet their cumulative travel will be vast. This journey will culminate in the gradual closing of oceans, the birth of new mountain ranges, and the fusion of land that reassembles a supercontinent. Scientists have projected several scenarios for this future supercontinent, earning it names such as a Pangaea Proxima or Gamma. The precise formation remains uncertain, yet the essence of the prediction is clear: continents will converge once more. The Atlantic Ocean may begin to shrink as subduction zones consume oceanic plates, pulling the Americas closer to Europe and Africa. In this vision, the Mediterranean Sea will vanish, replaced by a vast mountain chain stretching across southern Europe and northern Africa, a majestic barrier rising to immense heights, some peaks potentially surpassing the grandeur of modern-day Everest. Australia, a lone island continent today, will ride the currents of tectonic plates toward the Southeast Asian islands. This movement will compress archipelagos like Indonesia and the Philippines, remolding them into mountainous chains and altering coastal environments. The Indian subcontinent, long associated with its collision that created the Himalayas, will continue its northward push, driving further change and upheaval in topography. Meanwhile, the Americas will not be idle. Baja California, now a peninsula, will slide north alongside the western coast of what is now the United States and Canada, eventually fusing with those great landmasses. Mountain ranges will rise from these ancient collisions, reshaping local climates and ecosystems. The northern latitude landscapes will shift dramatically, with parts of Siberia moving southward into warmer climates, inviting new forms of life and vegetation to flourish. The Antarctic continent, now a frozen expanse at Earth's southernmost point, will not stay in place. It is envisioned that Antarctica will drift back toward the South Pole after roaming northward, gradually rebuilding its ice sheets that once again will hold vast reservoirs of frozen water, influencing sea levels globally. These surface changes are only one chapter of Earth's dynamic story. Beneath the surface, volcanic activity will persist, shaping the planet's face in sporadic but powerful ways. Supervolcanoes, capable of releasing thousands of cubic kilometers of ash and lava, will erupt, altering climate patterns temporarily and contributing to mass extinctions or evolutionary leaps. These phenomena will punctuate the slow, steady march of change with sudden, dramatic events. Erosion, sculpted by wind, water, and ice, will gradually wear down newly formed mountain peaks, redistributing sediments to oceans and inland basins. This interplay between tectonic uplift and erosive forces will continuously remodel Earth's surface, providing a seamless flow of creation and destruction. As the continents merge, the ocean basins will transform. The Pacific Ocean is projected to continue its slow contractions, becoming narrower as surrounding landmasses encroach. Other seas, such as the Tethys Ocean, long ago vanished, will remain history as new oceanic patterns emerge. Inland seas may appear where water collects in newly formed basins, while some coastal regions might drown under rising sea levels. The oceans themselves will be affected by changes in climate and geology. Their chemistry, temperature layers, and circulation currents will evolve, influencing marine ecosystems. Some marine habitats will thrive in these new conditions, while others will contract or disappear. Deep ocean trenches may harbor life forms currently unknown, adapting in darkness and pressure far from the warming surface. Earth's atmosphere will also undergo transformations. The Sun's gradual brightening over the next 100 million years will increase solar radiation, warming the planet. This warming may cause evaporation of surface water, shrinking ocean sizes and stressing water cycles. Complex atmospheric changes will create zones of extreme heat and dryness, balanced by pockets of humidity and rainfall supported by orographic effects of newly risen mountain ranges. These climatic shifts will influence the biosphere profoundly. The distribution of ecosystems will oscillate as deserts expand and contract, forests migrate, and tundras retreat. Life on Earth will push forward, resilient and innovative, navigating an ever-changing environmental canvas. Species will rise and fall, their fates linked to the slow motions of crustal plates and the volatile whims of climate. Within this grand geological and climatological framework, the story of Earth's future is a testament to fluidity and resilience. The slow, tectonic ballet setting the stage for life's drama will bring moments of serene stability punctuated by bursts of upheaval eruptions, floods, and mountain building that challenge and inspire new evolutionary paths. This dynamic balance of forces and cycles will continue to govern Earth's destiny. The planet's complex systems, tectonic plates, oceans, atmosphere, and living organisms interact in a web of cause and effect that unfolds on a grand timescale, far beyond the span of human lifetimes. Thus, in this envisioned future, Earth is a place not frozen in time, but alive and ever-changing. It is a planet where new mountains reach for the sky, ancient oceans vanish and reappear, and life finds wondrous ways to persist. As you rest, imagine the sweeping landscapes that will emerge: vast deserts, lush valleys, endless seas, each a testament to the power and patience of nature. Allow the gentle rise and fall of these images to calm your mind, as slow and steady as the movement of continents beneath the ground. Let the quiet epic of Earth's shifting face soothe your thoughts, inviting a deep peace as the planet's constant transformation continues, uninterrupted by the passage of time as we know it. Sleep now, held within the embrace of this future world's quiet grandeur, knowing that Earth's story is timeless, its heartbeat steady and enduring. The next million years await, full of mysteries, wonders, and life still to come. As the continents slowly glide toward their future unions, the atmosphere and climate that envelop our world will undergo vast and profound transformations. The Sun, the ever-present star at the heart of our solar system, continues its steady evolution. Each year, it grows imperceptibly brighter and hotter, infusing more energy into Earth's biosphere and atmosphere. Though this increase seems small in any moment, over the scope of millions of years it will have far-reaching consequences, gradually reshaping every corner of our planet. Picture the gentle warmth that rises as the solar energy increases, a slow crescendo building over tens of millions of years. This increased energy will accelerate the evaporation of surface water from oceans, lakes, and rivers alike. Vast stretches of water that once nourished life will shrink and retreat, forcing ecosystems to shrink with them or adapt to ever drier conditions. The persuasive pull of dryness and heat will spread across continents, carving expansive deserts and drying fertile lands. The familiar blue seas of today may become the rare jewels amidst sweeping expanses of barren land. With diminishing oceans, the balance of the water cycle will shift dramatically. Rainfall patterns will become unpredictable, shifting wet zones toward poles or high mountainous regions, while equatorial regions may grow harsher and more arid. The air itself, heavy and warm, will carry the memory of these changes, shaping cloud patterns and wind currents in unexpected ways. Storms might become fierce and volatile or, paradoxically, vast regions might become eerily still, locked in stagnation beneath burning skies. Yet even amid such potentially harsh climates, life's unyielding spirit will manifest in wondrous adaptations. Plants and animals will evolve new strategies to endure drought, heat, and scarce water supplies. Some species may develop waxy surfaces to minimize moisture loss, others might thrive despite high salinity in shrinking seas. Perhaps forests will migrate to pockets where water remains, adjusting their range and breadth to shifting climatic envelopes. Life might cling to life-giving refuges like mountain springs or subterranean caves, hidden from the broader harshness. In the carbon cycle, that delicate balance of carbon dioxide, oxygen, and other gases, complex changes will unfold as well. The increasing heat will accelerate chemical weathering of rocks, pulling carbon dioxide from the atmosphere and locking it into minerals more rapidly. Paradoxically, this might lead to reduced levels of carbon dioxide required for many plants, especially those that rely on the more common C3 photosynthetic pathway. This effect could cause widespread declines in forests dominated by trees and other plants, which form the backbone of many ecosystems. The decline will not be abrupt but a gradual fading across millennia. Yet in this shift, other plants utilizing the C4 photosynthetic pathway more efficient at lower carbon dioxide levels could continue thriving for much longer. Grasses and certain specialized plants might spread and diversify, creating ecosystems markedly different from today's green forests. This transformation will ripple through food chains, affecting herbivores and their predators, and ultimately the entire tapestry of life. As carbon dioxide declines, temperatures might begin to stabilize or even fall in some regions, creating new climatic niches. However, the overall warming trend, driven by the increasing solar flux, will persist and shape planetary weather patterns. The combined effect of solar heating and atmospheric shifts will prompt a future Earth marked by extremes, belts of blistering aridity and pockets of lush, if fragmented, pockets of hydration. The oceans, the planet's lungs and vast reservoirs of biodiversity, will mirror and amplify these environmental transitions. Shrinkage due to evaporation will alter ocean salinity, density, and circulation patterns. The great currents that sustain marine climates and carry nutrients will evolve or slow, influencing habitats both near the surface and deep below. Marine ecosystems once abundant with life might struggle against shrinking habitats or flourishing in newly formed niches, deep in the ocean's twilight zones or coastal refuges. As level waters retreat, continental shelves may be exposed, opening fresh lands that interlace with shrinking seas and newly forming lakes. These new landscapes will create a complex patchwork of environments where aquatic and terrestrial life forms intersect and adapt. Salt flats, mineral basins, and ephemeral seas might dominate in some regions, painting a unique geophysical mosaic unlike anything seen before. From above, the sky itself will reflect these shifting conditions. Changes in atmospheric composition will alter colors of sunrises and sunsets, clouds will take on new forms, from high wisps to dense, rolling masses, casting changing shadows over the evolving land. Light filtered through dust and aerosols from volcanic activity or desert storms may create horizons tinged with amber, crimson, or even violet, a constant reminder of the dynamic Earth below. Though climate models predict these sweeping changes over eons, Earth's history teaches that nature adapts, endures, and often surprises. Past episodes of warming and cooling, ice ages, and greenhouse periods have showcased life's resilience and tenacity. Over millions of years, extinct species were replaced by new ones, ecosystems rebounded from near disaster, and the planet remained vibrant with living processes. This future will be no different in its overarching theme of persistence and renewal. Throughout these changes, Earth's capacity to support complex life will fluctuate. Some scientists anticipate that over extraordinarily long timescales, hundreds of millions to billions of years, the combined pressures of increasing temperature, declining carbon dioxide, and reducing water availability may eventually bring large-scale extinctions. The trees, the largest carbon fixers, may die off, followed by declining populations of herbivorous animals and their carnivorous counterparts. Despite this, microbial life and extremophiles will likely persist in niches adapted to heat, acidity, or other harsh conditions, continuing the ancient legacy of life on Earth. Yet none of these vast transformations will escape the influence of chance events from the universe beyond. Asteroid impacts, although infrequent, could reset ecosystems abruptly. Massive solar storms might disrupt atmospheric chemistry and biological cycles temporarily. Cosmic radiation and other stellar phenomena may shape or erode parts of Earth's atmosphere, subtly adjusting conditions for life. These celestial influences underscore Earth's place in a vast and dynamic cosmos. As night deepens and quiet settles around you, allow these reflections on Earth's future climate to evoke both wonder and peace. The rhythms of natural cycles, eternal and immense, offer a soothing cadence that echoes through time. The slow dance of the planet, of atmosphere and ocean, land and sun, invites calm contemplation as the present melts gently into the far future. Envision the warm glow of a distant sun casting long shadows over deserts and mountains, the faint murmur of shifting winds through altered forests, and the deep, slow pulse of distant seas reflecting an ever-changing sky. Let these images cradle your thoughts, easing the mind and softening the edges of day. Feel the weight of time, not hurried, but steady and deep, as it carries Earth through this future of uncertain beauty. The planet's cycles of warming, drying, raining, and growing draw a grand portrait of transformation that, while vast in scope, enfolds us in a gentle embrace. Here, in this future world, the essence of life endures, quietly adapting, softly thriving. Now, with this vision accompanying your breath, ease further into comfort. As your body relaxes and the mind wanders into this tranquil realm, know that Earth's story is one of continuous change, an endless narrative woven through space, time, and life itself. Rest within that story, knowing you are part of a vast, beautiful continuum. Let the soft cadence of these words guide you into restful sleep, buoyed by the knowledge that, over millions of years, life finds a way. The planet's enduring transformations are a symphony of survival, whispered gently through ages to come. Earth's surface is a living, breathing canvas, constantly reshaped by the invisible yet relentless forces beneath. The great movement of tectonic plates embodies the planet's slow heartbeat, driving change over eons. As we journey further into the future, imagine how these colossal pieces of Earth's crust, some as vast as entire modern continents, will continue their slow, inexorable dance. The continents are not fixed, solid islands, they are giant rafts afloat on the molten mantle, drifting centimeters per year but moving thousands of kilometers over millions of years. In the next 50 to 100 million years, we can expect dramatic reconfigurations of land and sea. Scientists envision the gradual closure of the Atlantic Ocean as the Americas edge steadily toward Europe and Africa. the Mediterranean Sea will disappear under the weight of colliding plates, and a mountain range reminiscent of the Himalayas but even more majestic may rise, stretching from the Iberian Peninsula through the Mediterranean basin and into the Middle East. Imagine peaks soaring higher than those today, carved from the immense pressures of continental collision. Australia, once isolated, will slowly merge into Southeast Asia, compressing island chains and reshaping coastlines. Japan, currently an archipelago, may fuse with the Asian mainland, creating a continuous landmass that transforms climates and habitats. Meanwhile, the western coasts of North and South America will edge closer to Asia due to new subduction zones that consume the Pacific Ocean's floor, potentially forming towering mountain ranges along their margins. Far to the south, Antarctica, now enveloped in ice, will reverse its northward drift and return toward the South Pole, reforming vast ice sheets that will dramatically lower sea levels once again. The melting and refreezing of ice caps will cyclically reshape coastlines and ocean currents, influencing global climate and ecosystems. Throughout this geological choreography, volcanoes will continue their intermittent but powerful eruptions. Supervolcanoes, giants capable of spewing thousands of cubic kilometers of ash, may erupt, blanketing the sky and altering climate temporarily, creating shadows of darkness and cold that cascade across the Earth. These rare but forceful events will punctuate periods of gradual tectonic change with moments of sudden transformation. As mountains rise, erosion and weathering patiently sculpt them down. Rivers, driven by gravity and rainfall, carve valleys and transport sediments toward the oceans. The Earth's surface is thus balanced on a continuous cycle of creation and destruction. While tectonic forces push landscapes skyward, wind, rain, ice, and time wear them away, sending soil and minerals downstream to eventually settle on ocean floors, the birthplace of new rock. Inland, seas will shift and appear where they have long vanished, filling low basins and floodplains. Some ancient seas may reform, while others permanently vanish. As sea levels fluctuate due to melting glacier and changing ocean volumes, new coastlines will emerge, creating labyrinths of bays, rivers, and islands. These can become cradles for life or barriers shaping species distribution. On the ocean floors, tectonics will mold vast underwater mountain ranges and deep trenches, habitats home to countless unseen species. Hydrothermal vents may harbor extraordinary ecosystems, thriving without sunlight but depending on chemical energy from Earth's core. These environments remind us of life's adaptability and hidden wonders beneath our awareness. With the shifting continents and oceans comes the reorganization of global climate systems. Wind patterns, ocean currents, and temperature gradients will respond to these changes like a finely tuned orchestra. Monsoons might intensify or disappear as landmasses rearrange themselves, and jet streams may alter, redistributing heat and moisture across latitudes. These subtle changes, over geological timescales, will decide where deserts expand and rainforests thrive. A rising mountain range cools the air, squeezing moisture into rain, creating lush valleys adjacent to arid highlands. Conversely, vast deserts might stretch across continents as dry winds sweep inland. Once fertile regions may dry, pushing animal and plant communities toward survival strategies unknown to us today. In this new world, life will adapt or perish, guided by the merciless hand of Earth's changing face. The carbon cycle remains the unseen engine driving much of this climate change. This slow but powerful feedback loop regulates Earth's temperature and the health of ecosystems. Weathering of rocks captures atmospheric carbon dioxide, locking it away for millions of years, while volcanic eruptions release ancient carbon back into the air. The balance of these processes will determine how warm or cold the planet remains and govern the possibilities for life. Over millions of years, the future Earth may experience cycles where volcanic activity spikes, releasing vast carbon gases, warming the planet. These warming spells are sometimes halted by increased chemical weathering spurred on by rising mountains and rainfall, drawing carbon down and cooling the globe. This natural thermostat moderates extremes, allowing life to belt through episodes of hardship and recovery. In this continuous rhythm lies the heartbeat of Earth's resilience. While continents merge on a grand scale, the formation of future supercontinents like Pangaea Proxima or Amasia will bring profound environmental shifts. The vast interior regions will likely become dry and inhospitable, far from oceanic moisture sources. Yet, new coastal zones and mountain ranges will develop complex climates, nurturing pockets of biodiversity. Life must become ever more resourceful to thrive in the face of such variance. This cycle is not just geological, it holds deep significance for biological evolution. The formation of new mountain ranges, valleys, and climate zones creates isolated habitats where species may diverge and evolve uniquely. The Earth's evolving geography acts as the architect of biodiversity, defining corridors for migration and barriers for separation. Each fold and fault in the Earth's crust is a step in the great saga of life's unfolding drama. Even as ecosystems flourish or fade, the planet's slow tectonic pulse continues. The rate of plate movement may eventually slow compared to today, possibly leading to fewer earthquakes and volcanic events over time. Yet, the mantle beneath might heat up, releasing more magma and triggering bursts of volcanic activity, reminding us that Earth's forces are cyclical and ever-changing. From the highest mountains to the deepest trenches, Earth's landscapes will be endlessly rewritten. The crust's motion is a story without end, shaping a world in constant flux. This unceasing transformation is both a source of stability and renewal, underpinning the planet's capacity to sustain life through ages. So as you lie comfortably, contemplate this serene but powerful vision. The continents you know, the seas you journeyed across, the mountains you see, even the ground beneath your feet are but moments in the continuous shapeshifting of Earth. Feel the calm flow of geological time washing over you, vast and unhurried, carrying you gently toward rest. Know that in this immense, slow dance of crustal plates and volcanic fires, Earth's spirit thrives, nurturing life's endless story. Breathe deeply and sink into the tranquil rhythm of a planet forever moving, forever alive. As you drift slowly deeper, carry this thought with you: change is eternal, but so is renewal. Within the shifting grounds and swirling atmospheres, Earth's heartbeat echoes the pulse of a living world, cradling us gently through space and time. The Earth's climate is a delicate yet powerful system, shaped by countless factors that interplay over vast stretches of time and space. To step further into Earth's future is to witness the slow but sure transformation of this system, a transformation driven by forces both internal and cosmic, weaving together elements of atmosphere, ocean, land, and life in an intricate tapestry. As the sun continues its slow brightening, the atmosphere enveloping Earth will respond in profound ways. More solar energy means warming, but the planet's reaction is far from simple. The chemical balance of gases, especially carbon dioxide, oxygen, and water vapor, will shift gradually, orchestrating changes that ripple through air currents, precipitation patterns, and surface temperatures. Imagine a world where long familiar climates are displaced or completely erased. Regions that once fostered lush rainforests might become sparse woodlands or arid steppes. Tropical belts could expand or shift, while temperate zones compress. Polar ice, when it exists, will wax and wane according to this changing interplay. This dynamic will foster new patterns of wet and dry, warm and cold, wetness retreating and advancing like slow breathing. Eventually, the rise in solar brightness may tip Earth's atmosphere toward what scientists call a moist greenhouse state. This phase is characterized by an accumulation of water vapor in the upper atmosphere, increasing the greenhouse effect and pushing surface temperatures even higher. Such conditions could accelerate the evaporation of oceans, dramatically altering global hydrology. The delicate balance of life-supporting water will become a challenge unlike any in Earth's recent history. Evaporation will dwindle at the poles and equator, reshaping ocean currents that today distribute heat worldwide. Stronger evaporation may create large desert expanses covering continents formerly rich with life. The shift may expose vast salt flats where deep oceans once teemed with marine life. Yet even in these extremes, life will adapt. Some plants and microbes might survive in concentrated habitats, oases of moisture, or deep underground reservoirs. Carbon dioxide levels, crucial for the photosynthesis that underpins much of Earth's biosphere, will decline over time. As the planet warms, intensified weathering of silicate rocks pulls CO2 from the atmosphere, locking it into minerals. This slow geological process stabilizes temperatures but also reduces the carbon available for vegetation. Trees and other plants that depend on abundant carbon dioxide may struggle, with forests thinning and eventually giving way to grasslands or shrublands dominated by species with lower carbon requirements. This gradual reduction could ripple through ecosystems. Herbivores that rely on woody plants may decline, pushing some predator species and scavengers to adapt or vanish. Yet, ecosystems are resilient. New niches will emerge, filled by life forms attuned to the altered chemical environment and changing physical conditions. Microbes, especially extremophiles thriving in harsh niches, will likely persist far beyond flora and fauna. Meanwhile, Earth's oceans will continue their complex evolution. As ocean basins alter shape through plate tectonics and water volume fluctuates with evaporation and glacial cycles, marine circulation patterns will shift. These currents, essential for distributing heat and nutrients, may slow or reroute, profoundly impacting marine ecosystems. Deep ocean zones could harbor diverse, ancient life forms sustained by chemicals rather than sunlight, creating mysterious biospheres unseen by surface dwellers. Changes in sea level over millions of years will expose new continental shelves and flood plains, changing coastal habitats. Mangroves, salt marshes, and coral reefs will likely migrate or transform into new ecosystems, some thriving in freshwater or brackish settings if ocean salinity shifts. In places where seas retreat, inland seas or large lakes may form, offering fresh habitats for aquatic life and influencing local climates. The complex dance between the Earth's surface and its atmosphere will generate new weather patterns. Shifting jet streams and pressure zones might shepherd storms differently, moving rain belts to parts of the planet currently arid, and drying others that today enjoy ample rain. Intense storms and droughts will become part of the planet's evolving rhythm, with ecosystems and human descendants learning to endure and adapt. Yet, every cycle of climate change brings possibility. History shows that life, even under extreme conditions, finds ways to thrive and diversify. Evolution, propelled by environmental pressure, will craft new organisms suited to the world's emerging landscapes and climatic challenges. Life's exceptional versatility means that future Earth may support ecosystems as complex and vibrant as those we enjoy today, but radically different in form, function, and appearance. Above all, Earth's future climate speaks of endless resilience, the power of natural systems to balance, reform, and endure. This climate story is not a tale of mere destruction or doom, but one of transformation, hope, and renewal across incomprehensible spans of time. As you rest in this calm moment, envision Earth's skies overhead shifting from brilliant blues to sunset hues that blend into twilight purples. Feel the quiet presence of wind over ancient deserts and the soft murmur of waves on distant coastlines reshaped by millennia. Allow these images to lull your thoughts, marrying the vastness of future time with the intimacy of a serene night. Deepen your breath, slow your pulse. Let the cycles of Earth's enduring climate and life carry you gently into rest. Here in this boundless future, peace and possibility coexist, inviting you to drift into sleep beneath the watchful stars of an ever-changing, living planet. Long after our present day has faded into memory, Earth's future will be defined by cycles both immense and delicate. Among these, the formation of a new supercontinent stands as a monumental milestone on the horizon of geological time. Over the next 100 million years and beyond, the scattered continents will come together once more, forging vast landmasses spanning thousands of kilometers. This gathering will reshape climate patterns, oceanic circulation, and ecosystems on a scale both breathtaking and profound. Scientists envision multiple scenarios for the future supercontinent. One possibility is a giant landmass still called Pangaea Proxima or Vemasia, formed predominantly in the northern hemisphere, leaving southern continents like Antarctica isolated. Another might have a supercontinent sprawling across the equator, linking northern and southern continents in an immense connected land area. Regardless of the exact configuration, the result is the same, a transformation of Earth's surface that alters the planet's climate in extraordinary ways. When continents cluster together, they disrupt ocean currents and wind patterns that today regulate global climate. Warm ocean waters, which currently flow poleward, might no longer travel freely, changing heat distribution worldwide. This change could trigger a vast cooling of the northern hemisphere as ice sheets grow over the massive land blocks. Unlike modern ice ages, which last thousands of years, such a cool period might extend for tens or even hundreds of millions of years, creating a deep freeze unlike anything experienced before. Imagine a world where ice sheets blanket enormous tracts of land not just from pole to pole but covering great swaths of the supercontinent's interior. These frozen deserts would contrast starkly with smaller, isolated pockets of warmer climate at the edges and in mountainous refuges. The ice would reflect sunlight, further cooling the planet in a feedback loop that sustains the glaciation. Yet even in these frigid conditions, life endures. Past ice ages show us that biodiversity does not vanish but adapts. Creatures evolve new mechanisms for insulation and hibernation, plants survive in tough soils and short growing seasons, and ecosystems, though transformed, continue to flourish. Given millions of years, evolutionary processes will carve niches and fill ecological roles deliberately molded by relentless cold and snow. Beyond temperature and ice, the supercontinent will bear distinct geological features. Mountain ranges rising from tectonic collisions will shape weather by forcing air to ascend, cool, and release moisture as rain or snow. Deserts will stretch under rain shadows cast by these ranges, while fertile valleys will thrive in corridors shielded from extremes. The rearrangement of land will also affect the planet's rotational characteristics. As masses shift and the distribution of weight on Earth's surface changes, the length of the day might increase slightly over millions of years. This subtle slowing of Earth's spin will influence atmospheric circulation and ocean tides, adding another layer of complexity to future climates. Meanwhile, the oceans, which today cover most of Earth's surface, will shrink significantly. As continents connect and sea levels fluctuate, vast coastal shelves will be exposed, creating new plains and corridors for migration. Sea currents will reroute, and the nutrient cycles sustaining marine ecosystems will evolve. Life beneath the waves, from tiny plankton to massive whales, will respond with adaptations to new habitats, temperature regimes, and salinity levels. In considering this story of a future Earth shaped by supercontinental assembly, it is important to recognize the interdependence of geological and biological processes. The physical shifts of Earth's crust dictate climate zones, which in turn drive the evolution of life. Species emerge, thrive, adapt, and sometimes perish, their fates intertwined with mountains, rivers, seas, and the atmosphere. As we imagine this future, let the steady rhythm of tectonic change resonate with your breath. Feel the gentle motion of continents slowly converging over millions of years, a motion so gradual it evokes patience and endurance. Visualize the snow-capped peaks and frozen expanses spreading across the supercontinent's heart, contrasted with pockets of life clinging to existence at the margins. Consider the vast time scales at play. The movement of continents, the rise and fall of ice, the cycling of carbon and water, these take place over such long durations that they outlast countless generations, civilizations, and perhaps even species. In this perspective, the present moment softens, becoming part of an unending flow of transformation. The planet's future, shaped by these monumental forces, holds lessons in resilience and change. Just as life has found a way through past mass extinctions, ice ages, and shifts in climate, it will find its path forward through the next chapter of Earth's evolution. This is a story of enduring hope, of adaptation, and of the intricate beauty that arises when life and planet co-evolve across the ages. Now, as night deepens and your thoughts drift, embrace the calm brought by this vision of a far-distant Earth. The vast ice sheets, the towering mountains, the quiet shifting of continents all unfold in slow, majestic harmony. This is a world alive in its own ancient rhythm, inviting you into rest and renewal under the canopy of future stars. Allow the peaceful flow of these thoughts to guide you deeper into relaxation. Let the steady pulse of geological time, the immense scales of change, and the enduring pulse of life itself bring comfort and tranquility. Here, in the vast expanse of time yet to come, the Earth whispers its timeless story, gently lulling you into restful sleep. As Earth evolves over tens and hundreds of millions of years, one of the most powerful influences on climate and life will be the formation and dispersal of supercontinents. These colossal landmasses, created when Earth's drifting plates converge, dramatically reshape the planet's geography, climate, and ecosystems, creating cycles of warming, cooling, and environmental transformation that ripple through deep time. Supercontinents influence Earth's climate through multiple intertwined systems. When landmasses cluster, they alter the flow of winds and ocean currents that distribute heat around the globe. They expose vast tracts of land to the atmosphere, changing rates of weathering, which in turn regulate the amount of carbon dioxide, a key greenhouse gas, in the air. These processes create feedback loops that impact global temperatures, precipitation, and habitability. During periods when supercontinents assemble, the combination of reduced coastline and massive mountain ranges tends to increase the rate of chemical weathering. Rainfall poured over uplifted terrain reacts with silicate minerals, pulling carbon dioxide from the atmosphere and storing it in rocks. This process often results in long-term cooling trends, sometimes ushering in icy periods where glaciers advance across continents. The growth of ice and snow reflects sunlight back into space, magnifying cooling and stabilizing the climate in what is called the ice albedo feedback. Conversely, when supercontinents break apart, the global effect switches. Fragmented continents increase the amount of coastline exposed to oceans, reducing the effect of weathering and allowing carbon dioxide levels to rise. This increase in greenhouse gases warms the planet, encouraging lush vegetation growth and fostering biodiversity. Warm periods, called greenhouse climates, correspond with supercontinent dispersal and are often marked by high sea levels and flourishing ecosystems. Scientists studying Earth's past have identified multiple cycles of supercontinent assembly and breakup. Past examples include Rodinia over 1 billion years ago, and more recently, Pangaea some 300 million years ago. By studying these cycles, we gain insights into how climate and life evolved alongside geological processes. Future supercontinents will continue to shape Earth's destiny. One scenario predicts the formation of a supercontinent called Amasia, centered near the North Pole. This landmass could be surrounded by frozen seas and ice sheets, with cold, snowy conditions dominating much of the northern hemisphere. The ice albedo feedback would likely lower temperatures on the planet, creating expansive glacier and cooler climates. In this scenario, agriculture would be limited to coastal fringes and lower latitudes, where conditions remain milder. Another possibility, Orica, envisions a supercontinent near the equator. Concentrated at low latitudes, it would absorb more heat from the sun, perhaps leading to rising global temperatures. Without large polar ice sheets to reflect sunlight, planetary warming would accelerate. Rainfall might become more intense near coasts, but interior regions could turn into vast deserts under scorching sun and low humidity. In this scenario, parts of Earth would be nearly uninhabitable for most species. Both scenarios share features that highlight Earth's complex future. The interiors of supercontinents are likely to be dry, often called arid cores, because they lie far from ocean moisture and experience extreme temperature swings. These landscapes would be harsh environments, inhabited by organisms adapted to scarcity and extremes. Meanwhile, coastal zones would benefit from milder climate and abundant resources, fostering more diverse ecosystems. Volcanic activity associated with plate tectonics will continue to be a major driver of environmental change. The collision and subduction of plates build mountain ranges and produce volcanic arcs that can release vast amounts of greenhouse gases like carbon dioxide into the atmosphere. Large igneous provinces, immense volcanic eruptions forming flood basalts may inject aerosols and gases that temporarily cool climate but can trigger longer-term warming. Volcanism's dual role, both warming and cooling, adds to the dynamic balance shaping Earth's environment. While eruptions cause short-term climate disruptions, they also drive long-term geological and atmospheric processes that maintain the conditions necessary for life. In this way, Earth's interior and surface are locked in an eternal conversation, sculpting climates through deep time. Life itself will respond to these planetary rhythms. Periods of supercontinent assembly, ice age cooling, and environmental stress often correspond to evolutionary pressures. Mass extinctions can punctuate these times, wiping out many species but opening niches for new forms of life to emerge and diversify. Conversely, greenhouse periods heated by supercontinent breakup facilitate evolutionary radiations, where species flourish and ecosystems expand. This cycle of growth, decay, extinction, and renewal has defined Earth's biosphere for hundreds of millions of years. Future supercontinents will continue to act as both crucibles and refuges for life, shaping the course of evolution under pressures unimaginable in our current time. For humans or our descendants, these changes pose great challenges and opportunities. The future Earth, with its shifting continents, changing climate, and evolving ecosystems, will be a world vastly different from today. Survival will depend not just on adapting to new environments but understanding and respecting the planet's deep natural cycles. As night envelops you and quiet deepens, imagine resting on a land that stretches across what was once many continents. Feel the subtle weight of ancient mountains, rising and eroding as the vast supercontinent breathes slowly through geological time. Hear the distant rumble of volcanoes shaping the land and the faint whisper of ice melting and reforming. Sense the shift of climate and life, ever moving, resilient, and patient. Let the steady flow of these thoughts deepen your relaxation. With each breath, sink further into the timeless rhythms of Earth's future, his stories woven in stone, water, and life. Here in this far landscape of tomorrow, peace and wonder mingle, lulling the mind and body into restful sleep beneath a sky that has seen countless ages come and go. Earth's climate over the grand arc of geological time is a symphony composed by celestial rhythms and terrestrial forces. Among the most enduring influences shaping this symphony are the Milankovitch cycles, named for the Serbian mathematician Milutin Milankovitch, who first theorized the connection between Earth's orbital variations and climate patterns. These cycles describe how small but dynamic changes in Earth's orbit and axial tilt create rhythmic shifts in climate that have orchestrated ice ages and interglacial periods over hundreds of thousands to millions of years. At the heart of these cycles are three orbital rhythms. First is eccentricity, the shape of Earth's orbit around the Sun, which oscillates from nearly circular to mildly elliptical and back over roughly 100,000-year intervals. This subtle shift alters how far Earth travels from the Sun at various points in its journey, changing the amount of solar energy reaching our planet. Second is axial tilt, or obliquity, which varies over about 41,000 years. The tilt influences how sunlight is distributed across the hemispheres, affecting the severity of seasons. When tilted more steeply, winters grow colder, summers warmer; when tilted less, the seasons moderate. Third is precession, a slow wobble in Earth's rotation axis occurring approximately every 26,000 years, shifting the timing of seasons and thus affecting climate patterns. Together, these cycles weave an intricate pattern of climatic ebb and flow. Over the past million years, they have driven glacial and interglacial periods, where ice sheets expand to cover large portions of continents, then retreat, revealing temperate conditions. These cycles explain much of the Earth's recent climate variability, and beyond that, they offer a window into the vast temporal scales on which our planet's environment shifts. Imagine now the next million years, then 10 million, all the way to 100 million years in the future, when these cycles continue their quiet dance. The interplay of eccentricity, tilt, and precession will still govern the timing of glacial advances and retreats, but combined with progressively changing geological and atmospheric conditions, higher solar luminosity and shifting continental formations will result in climates that may differ in intensity and rhythm from those of recent epochs. As Earth's plates continue their slow migration towards supercontinent assembly, the resulting shifts in landmass location will modulate the effects of the Milankovitch cycles. Large continental interiors will remain colder and more arid during glaciations, while coastal regions may enjoy milder, wetter conditions, enabled by proximity to shrinking but critical oceans. The overall effect could see ice ages with pronounced regional variation, ice sheets growing thick and vast over some regions while others remain ice-free refuges for life. In this future, the length and intensity of ice ages might alter. The frequency of glaciations may extend or shorten depending on how Earth's delicate climate systems respond to increasing solar output. At some point, Milankovitch pacing could be overwhelmed by the steady brightening of the Sun, a gradual but inexorable rise that warms the planet and accelerates the loss of ice. This leads to a profound future scenario, where Earth edges into what scientists call a moist greenhouse state, drying oceans and intensifying the greenhouse effect. Rising temperatures cause water vapor, itself a potent greenhouse gas, to accumulate in the upper atmosphere, trapping heat and fueling further warming in a feedback loop. This process accelerates the evaporation of Earth's surface water, reducing oceans and increasing aridity on land. With the gradual loss of ice sheets, large parts of Earth that were once cold and frozen transform into warm, often hot environments. Deserts expand dramatically, with much of the supercontinent's interior regions becoming increasingly inhospitable. Rare water sources become vital oases, supporting pockets of life resilient to heat and dryness. Atmospheric chemistry will shift as well. Carbon dioxide, essential for photosynthesis, declines as silicate weathering intensifies under increased solar radiation. This decline will challenge many plant species, especially those requiring higher CO2 for carbon fixation. Grasses and some specialized plants may persevere, but large forests could diminish, shrinking habitats for herbivorous animals and those that depend on them. In the oceans, warming waters alter marine circulation and ecosystems. Nutrient cycling changes as currents slow or redirect. Acidification risks increase with changing dissolved CO2 concentrations, stressing coral reefs and shell-forming organisms. Life in the deep ocean may endure changes slower, but surface marine biodiversity will face significant challenges. Amid such grand climatic shifts, Earth's biosphere will be forced into cycles of adaptation, decline, and renewal. The tenacity of microbial life, extremophiles, and hardy plants and animals will define the future of life on our planet. Mass extinctions may accompany these transitions, but new forms of life will evolve, filling niches and continuing the story of evolution on Earth. In the celestial context, Earth remains vulnerable to occasionally catastrophic events, asteroid impacts, nearby supernova explosions, or intense solar flares could cause abrupt climate alterations, resetting evolutionary tracks or causing rapid environmental changes. Yet, despite such upheavals, Earth's natural rhythms endure, cycling through patterns of ice and warmth, drought and abundance. As night closes around you and your breath settles into a calm, even rhythm, picture these vast cycles unfolding over the horizon of time. See glacier expanding and retreating, deserts raging and retreating, ocean swelling and receding, and life pushing forward with relentless grit and resilience. Let the slow, deliberate rhythms of Earth's orbital dance soothe your mind. With each inhalation, draw in the vastness of temporal scales, the patience of geological time, and with each exhalation, release any tension, stepping deeper into relaxation. Feel the gentle rocking of Earth in space, the slow waxing and waning of ice and warmth, the eternal flow of life against the backdrop of immense time. Here, in this space between consciousness and dreams, let these visions cradle you, guiding you into deep, restorative sleep. Know that these cycles, vast and ongoing, are the pulse of planet Earth, the unending heartbeat that carries all life through the ages, from ice to warmth and back again, in a timeless embrace. As we journey further along Earth's immense timeline, the vast tapestry of changing climates and landscapes continues to unfold in ways both breathtaking and humbling. The story of Earth 100 million years from now is painted with strokes of geological transformation, climatic shifts, and the resilience of life in the face of eternal change. Imagine, then, that by this distant future, the continents have long shifted from their present positions. The ocean basins have narrowed or expanded in response to tectonic forces, sewing together new oceans and supercontinents. These colossal landmasses redefine Earth's temperature gradients, weather systems, and ocean currents. The Mediterranean Sea may have vanished, replaced by towering mountain chains where Europe and Africa collided. Australia, once a solitary isle surrounded by ocean, now glues itself to southern Asia. The Americas inch slowly toward, or away from, Afro-Eurasia, depending on the scenario unfolding beneath our feet. The consequences for Earth's climates are profound. Imagine a world where supercontinents influence atmospheric circulation so drastically that entire continents can possess deserts stretching thousands of kilometers, baked by the relentless sun with scarce rainfall. Conversely, coastal regions nurture fleeting oases of rain and vegetation, vibrant pockets amid expansive aridity. The patterns of winds grow more complex under the influences of towering mountains and shifting seas, creating microclimates as varied as the landscapes themselves. These dramatic tilts shaping the planet do not occur in smooth, predictable ways. Volcanic eruptions, triggered by tectonic collisions or the shifting mantle, inject massive quantities of ash and gases into the atmosphere, stirring tempests and altering global temperatures. Some eruptions may trigger brief ice ages by shading sunlight, while others pump greenhouse gases that fuel warming over millennia. This dual effect ensures Earth's climate is never static but an interplay full of surprises and balances. As the ocean's shape changes, so too does the life it supports. Some marine corridors close while new pathways form, isolating or reunifying populations of sea creatures. Coral reefs, cradle of immense biodiversity, may flourish in new coastal enclaves or suffer decline in warming, acidifying waters. Deep ocean trenches and hydrothermal vents could host ancient, hardy life forms, shining hints of resilience under crushing pressures and complete darkness. Amidst this shifting scenery of rock and water, the air itself dances to a complex tune. The slow but steady increase in solar output brightens and warms the outer shell of Earth's atmosphere. This gradual heating intensifies evaporation from lakes, rivers, and seas, redistributing water vapor into clouds and storms with changing geography. Rainfall, vital for life, shifts in fickle rhythms, nourishing some places while desertifying others. Across land, plants and animals continue their age-old struggle for survival and adaptation. New species arise from ancestral lines, molded by the environment's relentless hand. Some develop strategies to conserve precious water, while others exploit new niches carved by climate or topography. Evolution, the great sculptor of life, never ceases, working slowly but impressively over these vast epochs. The future Earth is a realm of contrasts, where frozen glacier might cling to snow-capped mountains even as deserts expand below. Ice sheets wax and wane in tune with the changing tilt of Earth's axis and atmospheric chemistry. The interplay of these elements may cause episodes of intense cold stretching for tens, even hundreds of millions of years, punctuated by intervals of warming and flourishing. The arrival of supercontinents also signals shifts in Earth's carbon cycle. Chemical weathering of uplifted landmasses locks carbon dioxide into sedimentary rock, pulling greenhouse gases from the atmosphere and cooling the planet long-term. Yet volcanic activity returns carbon to the air, fueling cycles of warming. These processes interact in a planetary dance, maintaining Earth's habitability but also defining periods of extreme climate. Reflecting upon these future epochs, one appreciates the extraordinary resilience encoded in the biosphere. Life has weathered past mass extinctions and climatic upheavals, re-emerging with renewed diversity. Over the next 100 million years, this resilience will be tested and shown yet again, as species adapt or disappear. Microbial communities, extremophiles, and perhaps new forms of life will endure where others falter. Meanwhile, the human imprint may fade into geologic memory. Monuments, cities, and artifacts may be buried beneath sediments, eroded by time and nature's reclaiming forces. If humanity or its descendants endure, they may evolve beyond recognition or perhaps inhabit realms beyond the biosphere, digital or off-planet ecosystems imagined now only in dreams. For now, as darkness settles across your room and the sounds of the present world soften, allow your mind to wander through these vast cosmic perspectives. Feel the slow, steady march of time, the gradual weaving of continents, the rise and fall of seas, the dance of life in its infinite forms. With each breath, sink deeper into this peaceful vision of Earth's far future, a story of transformation, endurance, and subtle beauty etched across millions of years. Let the gentle cadence of this narrative shade your thoughts, nudging you softly towards calm and restful sleep beneath a sky that has witnessed eons come and go. This portion elaborates future continental configurations, climate consequences, volcanism, ocean life changes, and evolutionary resilience with a soothing, calming tone. If longer expansions or additional themes are wanted, they can be developed further. Continuing with Part 9, expanded and immersive as requested. As we look forward across the vast canvas of deep time, the story of Earth 100 million years from now unfolds slowly yet with monumental significance. The continents you know today will have continued their ceaseless wanderings, shaped by unrelenting movements of tectonic plates beneath the surface. These movements rewrite the planet's geography and give rise to new mountain ranges, oceans, and vast supercontinents, creating conditions both challenging and incredible. Consider the fate of oceans as this drama plays out. Continents converging will narrow ocean basins. Some might shrink into mere seas, others could even vanish. The Mediterranean Sea, for instance, long a cradle of human civilization, may not exist as we know it, replaced instead by towering mountain chains forged in the collision of Europe and Africa. The Atlantic Ocean, growing narrower as the Americas inch closer to Europe and Africa, will alter ocean currents and climate patterns, cascading climatic effects across the world. The merging of continents into vast supercontinents, sometimes called Pangaea Ultima, Amasia, or Aurica, will dramatically reshape climate zones. Large inland areas may experience extreme weather, scorching deserts, cold deserts shaped by rain shadows, extreme seasonal swings. Coastal fringes will offer milder climates where forests, rivers, and diverse life may flourish, while vast interiors could become sparsely inhabited. The shift in geography will profoundly affect atmospheric and oceanic circulation. With fewer coastlines and no small, scattered islands, winds and sea currents will behave differently. The heat from the sun will redistribute unevenly, creating more extreme conditions. Mountain ranges that grow taller and wider during continental collisions will force air currents to rise, cooling and condensing moisture, creating new rain patterns that nurture life in isolated valleys, while large rain shadows promote aridity elsewhere. Volcanic activity, fueled by these titanic shifts, will remain a force of transformation. Massive volcanic eruptions will pump ash and gases high into the atmosphere, temporarily blocking sunlight and cooling the surface. Yet the same eruptions release greenhouse gases like carbon dioxide, slowly warming the atmosphere again. This push and pull shape the planet's climate cycles over millennia, keeping Earth's temperature within bounds that, for millions of years, support life. Life's incredible resilience will be on full display. Species will evolve to fit new niches carved by shifting climates and terrains, plants and animals adapting to desert heat, mountain cold, or shrinking coastal wetlands. Some lineages may vanish during climatic extremes, while others radiate into forms unseen today. Microbial life, ever adaptable, will persist in extremes of heat and cold, acid and anoxia, reminding us of life's durable spark amid change. As the cycles of ice sheets, oceans, mountains, and deserts continue, Earth will witness periods where glaciers expand greatly, followed by epochs of relative warmth. Ice ages lasting tens or hundreds of millions of years might come and go, a rhythm far slower and deeper than recent glaciations experienced by humans. These long ice ages may cover large parts of supercontinents with glacier that sculpt the land anew, forming great valleys and shaping future ecosystems. Earth's carbon cycle will interplay with these grand transformations. Chemical weathering of exposed rocks during mountain building removes greenhouse gases from the atmosphere, cooling the planet over geologic time. Volcanoes and geothermal activity intermittently restore carbon dioxide, maintaining a balance essential for sustaining life. Humanity, or whatever descendants of humans endure, might find themselves changed beyond recognition, their legacy layered beneath sediment and tectonic shifts. Perhaps, on some distant future Earth, intelligent life thrives in ways we can scarcely imagine or migrates beyond Earth altogether, embracing digital or cosmic existences. Tonight, as shadows deepen and the world grows quiet, allow yourself to drift with these visions of Earth's distant future. Feel the weight and wonder of geologic time as continents convene and part, as climates sway in vast cycles, as life persists and evolves in endless creativity. With each breath, sink deeper into restful calm, cradled by the still unfolding story of a world forever in motion. Let this gentle imagining lull your thoughts, guiding you softly into sleep. The journey of Earth continues beyond the horizon of time, carrying all living things on a shifting, wonderful voyage beneath the stars. In the far reach of time, where the present feels like a fleeting whisper in the boundless expanse, Earth's destiny unfolds with a grandeur that stretches across epochs. The 100 million years that lie ahead promise a landscape and a climate as dramatic and varied as the history that has shaped our world thus far. This final chapter invites us to journey into the deep future, where the forces of nature, evolution, and cosmic influence converge to sculpt a planet both familiar and profoundly alien. By this time, the continents will have undergone a monumental dance, colliding and merging yet again to forge new supercontinents. These vast landmasses reshape the planet's climate systems, ocean circulation, and biospheres, setting the stage for environments that challenge the very definition of habitability. The weather patterns are rewritten by the mountains' rise and the seas' retreat, producing regions of intense heat and stark cold, lifelong deserts, expansive ice sheets, and verdant coastal refuges. Envision a planet where the geography molds the climate so intricately that every valley, plateau, and basin carves its microcosm of life and weather. Among the most striking consequences of these massive land formations is the alteration of ocean patterns. The great currents that today ferry warmth from equator to poles may vanish or redirect, replaced by new flows shaped by narrowing seas and expanding land. These shifts have a profound effect on global temperatures, polar ice formation, and the distribution of marine life. The seas may grow saltier and shallower in some regions as evaporation outpaces replenishment, giving rise to salt flats and mineral-rich deserts where once teemed coral reefs and thriving aquatic life. Earth's atmosphere, meanwhile, responds to the changing land and sea in its own vast rhythms. Solar radiation grows more intense over geological time as the sun brightens, driving evaporation and amplifying the greenhouse effect. A moist greenhouse phase may take hold, raising surface temperatures significantly and accelerating the loss of oceans through photodissociation in the upper atmosphere. Water molecules, broken by solar ultraviolet rays, release hydrogen into space, slowly desiccating the planet. This gradual but relentless evaporation transforms Earth's blue seas into shimmering salt plains, reminiscent of the driest deserts of today but on a planetary scale. Life, ever tenacious, adapts and evolves throughout these sweeping changes. The botanical stage will shift to favor plants that can endure low carbon dioxide levels and extreme aridity. Grasses, shrubs, and specially adapted succulents could dominate vast swaths of land previously covered by forests. Animals will evolve alongside these plants, finding niches in harsher climates, where water and shelter are precious commodities. Microbial life, often overlooked but vital, will thrive in extremes inaccessible to larger organisms, preserving the spark of life even as surface ecosystems transform. Beneath the waves, the oceanic biosphere contracts and contorts but does not surrender. Sheltered by deep trenches, hydrothermal vents, and isolated sea pockets, marine life endures and adapts. Creatures unheard of today may roam these waters, their biology tuned to high temperatures, pressures, or chemical compositions that seem otherworldly to the modern observer. Against this evolving backdrop, human presence, if it survives, will be but a distant memory or wholly transformed. Civilizations as we know them may have faded or evolved beyond current comprehension, possibly finding refuge in off-planet enclaves or transcending biological forms altogether. The legacy of human ingenuity, culture, and impact may persist as faint geological traces or in digital archives preserved in ways yet to be imagined. The story of Earth in 100 million years is one of change, continuity, and resilience. It is a testament to nature's power to endure and adapt, offering lessons about impermanence and hope. As the continents shift, climates swing from ice to heat, and life finds new ways to flourish, the planet spins silently through the cosmos, a timeless emblem of transformation. As your breathing deepens and your waking world fades away, Imagine yourself gently cradled by this vast future, a world in slow, majestic flux. Let the images of distant mountains, vanished seas, scorched deserts, and icy realms fill your mind's eye, bringing a sense of peace and awe. Feel the ancient rhythms of the planet's heartbeats pulse softly beneath you, guiding you into restful sleep filled with dreams of Earth's endless journey. Know that in the stillness of night, while stars wheel overhead and silence reigns, Earth's grand story continues, ever moving, ever changing, ever alive. Now rest, embraced by time and space, carried forward on the gentle tides of a future yet to be written.